Let's continue our discussion of one-step equations by looking at activity 3, which is going to involve writing equations ourselves. So to practice this, we're going to look at a series of real-life examples and see if we can translate those into an equation and find the solution. Let's look at number 1. Kieran's backpack weighs 3 pounds less than Claire's backpack. Claire's backpack weighs 14 pounds. How much does Kieran's backpack weigh? So when you're dealing with a problem like this, the first thing that you really want to do is think about what is it that you're trying to find? What is it that you don't know? And also, what is it that you do know? But when you're writing an equation, you really want to think about what you don't know. So what we don't know is generally what we're being asked for. How much does Kieran's backpack weigh? We don't know that. So we need a variable to represent that value. So you can pick whatever variable you want. Down here in part B, we see a bunch of equations and they all have the variable x. So let's go ahead and choose the variable x. And so the variable is going to represent the weight of Kieran's backpack. So let's write that down. And we want to think about what unit of measurement is going to be used. Weight of Kieran's backpack. All right, so up here we've got things in pounds. So I assume, we could do it in whatever we want. We could change it to ounces if we want, but let's just keep it in pounds since all the other information is given in pounds. Circle all the equations that describe the situation. So there could be more than one way to write an equation for this. Now, we don't have it here as part of this problem, but I think drawing a picture of some kind can be really helpful for visualizing what's happening, whether that's a number line or, you could draw a vertical number line or a horizontal number line. Let's go ahead and let me draw a horizontal number line. And it says that Kieran's backpack weighs 3 pounds less than Claire's, and Claire's backpack weighs 14 pounds. So on this number line, maybe I'd put a 14 here and label that with a C. That's Claire's backpack. That's 14 pounds. So these values represent pounds. So we could make a number line like this and kind of visualize what's happening. So there's Claire's backpack. It weighs 14 pounds. And we know Kieran's backpack weighs 3 pounds less. So we could visualize this on a number line by moving 3 places to the left. All right, Kieran's backpack weighs 3 pounds less. So Kieran's going to be 3 places, 3 units to the left this way. And that's going to be Kieran. So with that in mind, we could probably figure out how much Kieran's backpack weighs just by looking at this line. That's great, but let's think about how we would write an equation and which one of these equations would represent the situation. So remember, in our scenario, x was the weight of Kieran's backpack, even though we could just count on this number line and figure it out now. But looking at these equations, which one of these equations could be represented by could be used to represent this scenario? Why don't you take a second, pause the video, and circle all the equations that you think would work here. All right, well, hopefully you picked this first one. What I like to do when I'm reading these equations is literally substitute in for x this phrase. This is what x represents, right? So what if I read this and I say, instead of saying x plus 3 equals 14, I say the weight of Kieran's backpack plus 3 equals 14. That's true, right? The weight of Kieran's backpack plus 3 would give me Claire, so that would work. All right, how about this one, this second one here? 3 times the weight of Kieran's backpack is 14. No, that's not right. How about this one? Kieran's backpack is 14 pounds, take away 3 pounds. Yes, definitely. That one would work. And how about this one? Kieran's backpack is 14 pounds divided by 3. No, that's not correct. All right, so these two would work. So now to find the solution, we've got a myriad of ways of looking at this with the line diagram or actually just doing 14 minus 3, but I think we have it figured out by now. The solution is 11 pounds. That is the solution. And make sure to label your answer with the correct unit. All right, let's take a look at number 2. Each notebook contains 60 sheets of paper. Andre has 5 notebooks. How many sheets of paper do Andre's notebooks contain? All right, so what is our variable going to represent here? Well, again, that's the thing we don't know. That's the thing we're looking for. And so that's going to be the sheets of paper that Andre's notebook contains. So the variable is going to represent the number of sheets of paper in one notebook. No, all the notebooks, right? And he has 5 notebooks. Number of sheets of paper in all Andre's notebooks. Okay, take a second, pause the video, and decide which of these equations would be appropriate to represent this situation. Start the video when you're ready. So again, I always think it's a good idea to draw some kind of visual if you're having trouble, or even if you're not, just to get your brain working. So I'm drawing a picture of what's happening here. It says each notebook contains 60 sheets of paper, and Andre has 5 notebooks. So here's Andre's 5 notebooks, and I know each of these notebooks contain 60 sheets of paper for each notebook. And so Y is the total number of sheets of paper in Andre's notebook. So Y is going to be the total amount of paper in all these notebooks. We could even use that tape diagram, right? Oh, that's not going to work. I was going to move my squares. If I moved my squares together like this, we could make a tape diagram out of it. And each of these notebooks is worth 60. Let's do it that way. That's kind of fun since we did tape diagrams before. So each of these squares, rectangles, whatever, represents a notebook, and then they have 60 sheets each, and the total sheets of paper is Y. All right, so certainly this first equation looks pretty good. Y equals 5 times 60, right? Because we have 5 60s added together. How about 5 times Y equals 60? Is that going to work? 5 times the number of sheets of paper in Andre's notebook. Y is the total number of sheets equals 60. That's not going to work, right? Can you see that? 5 times the total sheets isn't going to give you 1 notebook worth. So that's not going to work. How about this one? The total number of sheets divided by 5 equals 60. That's going to work, right? The total number of sheets divided by 5 notebooks is going to give you how much paper is in 1 notebook. How about this last one? The total sheets of paper is 60 sheets divided by 5. That's not going to work, right? The total sheets is more than that. So what's the solution? Well, you've probably got that part figured out by now, which is 300. 300 sheets of paper. And make sure to label your answer. All right, let's take a look at number 3. The Seahawks score 10 more points than the Rams. If the Seahawks score 24 points, how many points did the Rams score? So go ahead, pause the video, and work this one all out on your own, and then unpause it when you're done. Do the whole thing. All right, let's take a look at the first part and see how you did. Part A, what does the variable represent? Again, that's what we're trying to find, so we don't know how many points the Rams scored. So that's what the variable is going to represent, the number of points the Rams scored. Part B, we're asked to write 2 equations that describe the situation. Now, in these first questions we did, 1 and 2, we were given the equation and we had to pick the ones that describe the situation. So here now we're asking you to write an equation. So you need to decide what variable you want to use. X, Y, R. Sometimes it's nice to use a variable that, you know, shares a letter with what you're trying to find, like P for points or R for rams or something like that. Now I drew a number line here to try to visualize what was happening. It says the Seahawks scored 10 more points than the Rams, and the Seahawks scored 24 points. So I made a number line and I made the Seahawks 24 points. Now, where would the Rams go? Could you put the Rams on the number line here? The Seahawks scored 10 more points than the Rams. 10 more points than the Rams. So there's a 10-point difference here. The Rams are going to be down here somewhere, right? They're going to be less. So this distance is 10. Maybe I could do that with a little, let's do like this. That's 10. And so maybe this will be my variable. Now you guys could probably got a number in mind, but remember this is your variable. I'm going to choose R for Rams. Okay, and this is capital R, and my variable will be little r. And capital R stands for the Rams, and S is the Seahawks. Okay. So now we need to write two equations. If you haven't got the equations yet, or you want to modify what you did, pause the video and go back and do B again. But if you have your equations, let's see what we could come up with. So looking at this diagram, looking at this number line, I see a few things. I see if I start at R and add 10, I'll end up at 24. So one equation could be R plus 10 equals 24. Another equation I see is if I start at 24, I could subtract 10 and I would end up at R. So I could say 24 subtract 10 equals R. Another equation that you might see is the difference between 24 and R is 10. So you could say 24 take away R equals 10, right? The Seahawks score take away the Rams score is 10. You could do that. I can't think of any others off the top of my head here. If you have another one that you think might work, you could email your instructor and get some feedback about that. All right, so find the solution. Well, we could look at any of these, look at this number line and think about it, and it looks like the Rams have 14 points. Rams scored 14 points. All righty. Again, I really encourage you to use some kind of a visual, right? We have this number line, we have this tape thing. Again, up here I used a number line. It can really be helpful for visualizing what's happening. All right, let's look at number 4. A patient is prescribed an IV drip of 250 milliliters. The IV drip dispenses at 85 milliliters per hour. How many hours will the patient be on the IV? Okay, pause the video, draw a picture, write your variable, spend some time thinking about it before you listen to me talk about it. All right, let's see if you've got your variable defined. How many hours will the patient be on the IV? That's what we don't know. So we want the variable to represent the number of hours the patient is on the IV. And I'm going to go ahead and put my variable there, what variable I want to choose. I'm going to choose H to be hours. If you picked a different variable, that's fine, no problem. I want to show you a tool that you can use for a problem like this called a double number line. So I have a line here. And I'm going to put a mark, and I'm going to represent one thing on the top and a different thing on the bottom. So on the bottom, I'm going to call this hours. So we're going to start at 0 hours. And on the top, I'm going to call this the total number of milliliters, all right, the total milliliters. So at 0 hours, the patient has received 0 milliliters. So let's go one more hour here. So after 1 hour, how many milliliters will the patient have received? You got it? Well, we know it's 85 milliliters per hour. So after 1 hour, the patient will have received 85 milliliters. How about 2 hours? The question is how many hours until they get to 250 milliliters, right? So we could use this tape diagram to kind of visualize. This isn't a tape diagram, double number line diagram to figure out what's happening. So after 2 hours, it'd be 85 plus 85. So that would be 170 milliliters. After 3 hours, we'd add another 85 to this, so that'd be 255. And we can see that after 3 hours, they have received more than the 250 they need. So the answer is going to be somewhere less than 3 hours. So this gives me a little bit of an idea about what the answer is. It didn't come out perfect, but that's okay. So I know that they're getting 85 milliliters for every hour. So my equation, I could say 85 milliliters times the number of hours, and I need that to come out to be 250 milliliters. Or you could say I've got 250 milliliters and I'm going to divide that by 85 milliliters per hour, and that'll tell me the number of hours. Okay, so those will both work. So now to figure this out, you actually are going to do 250 divided by 85. And if you punch that into your calculator, 250 divided by 85, you get like 2.94 approximately hours. You could write that as a fraction, but since we're talking about time, it makes more sense to write it as a decimal. We could change this to minutes. Let's just practice that right now. So we've got 2 hours, and then we have like 0.94 hours. So what I want to do here is kind of think about splitting this up. I've got 2 hours, and I've got some decimal portion of an hour, and I really want to change this into minutes. So to do that, I'm going to multiply 0.94 by 60. Okay, I'm going to go over here and show that. So if I have 0.94 hours, I can multiply. I know there's 60 minutes per every 1 hour. So I'm going to cancel these hours out, and I'm going to multiply 0.94 times 60. And that's going to give me about 56 minutes. It says 56.4. So let's just round to the nearest minute and say 56 minutes. I guess depending on what's in this IV, depends on how accurate we want to be. So H is about 2 hours. I mean, we could go to seconds. That could be fun. You want to do that? You're like, no. So we'd have 56.4 minutes. If we wanted to go to seconds, yeah, I'm going to do it. All right, we have 56.4 minutes. So 56.4 minutes would be 56 minutes, and then you've got 0.4 of a minute. All right, so how can we change this into seconds? So 0.4 minutes, we would multiply by 60 again, right? So we have 60 seconds in every 1 minute. So the minutes will cancel, and I'll take 0.4 times 60. I mean, this is medicine. We should probably be pretty accurate, right? I don't know. I'm not a doctor. 24 seconds is what that comes out to be. Okay, where can I write this? I got quite a mess here. So my final answer, even though I rounded this 0.94, and now I'm trying to be all super accurate, is 2 hours, 56 minutes, 24 seconds, which I think we can write as 2.56.24. That's really how we would say that, right? We wouldn't say 2.94 hours. We would want to know how many minutes, and if necessary, how many seconds, depending on the level of accuracy that we needed. Let's look at one of these last two. Let's look at 5, and then I'll leave 6 to you. Number 5, in a survey about work-life balance, 1/3 of adults stated they were happy with their current work-life balance. The number of adults in the survey who report they are happy with their current work-life balance is 120. How many adults were surveyed? All right, what's our variable going to represent? How many adults were surveyed? That's what our variable is going to represent. So let's say number of adults surveyed. What variable do we want to use for this? How about A for number of adults? Okay, let's see if you can write an equation. Pause the video, restart it when you think you have an equation. All right, let's see if we can draw a picture of this. 1/3 of adults say they were happy, and the number of adults who say they're happy is 120. So we've got some larger number of people that were surveyed. So this is the total number of people surveyed, all right? This is what we don't know. So I'm going to call this A. And it says that 1/3 of all these people say they were happy. So let's split this into thirds. And let's put yellow for the people that are happy. Yellow, sunshine, happy people. So how many people were happy? This is 1/3, right? This yellow part is 1/3 of the entire number of people surveyed. And that was 120 people say they're happy. 120. Okay, and each of these rectangles is supposed to be divided equally, right? 1/3. So looking at this diagram, if I'm thinking of an equation, I could say, well, I know that I have 3 120s, and that equals A. I could say A divided by 3 is 120. Right? I take the total A and divide it into 3 pieces. I could say A divided by 120 is 3. Any of those would work. So the solution here is we've got 2 more thirds that are unhappy. I'll put red for unhappy, and each of those is 120. So it looks like we have a total of 360 adults surveyed. Oops, surveyed. Okay, I'm going to leave number 6 to you. I would like you to try number 6 before you submit your work, and then we will finish up this section with one more activity.